Making sense of radians and arc length. What the heck does this formula mean? Let's approach it from the mindset of a fifth grader. If you ask a fifth grader, how many $5 bills does it take to make $85? They could figure it out and tell you 17 bills. You just got to divide, right? Look at this. So $85 total. I take the value of each bill and multiply it by the number of bills that I have, right? Simple math. It's the same simple math that's right here. Check it out. I'm going to wrap radiuses around the circle. See how I have one radius wrapped around the circle? That arc length is 3. When I wrap around 2 radiuses around the circle, I have an arc length of roughly 6, and so on and so forth, right? So right here I have 3 radiuses. I know the math is off just slightly, but look here, right? If I want to find arc length, simply take the length of one radius and multiply it by the number of radiuses you wrap around. That's what that theta represents. Theta in radians is the number of radii, or the number of radiuses you wrap around that circle to make the full arc. Watch this. I'm going to make it go to 3.14, the radians there. And oh, I just did. Look at that. Don't we always say pi radians is the same as 180 degrees? Why is that? Well, look at the diagram here. Doesn't it take 1, 2, 3.14 radiuses to make a half of a loop? So pi radians is really 3.14 radii wrapped around the circle, and that goes to the halfway point. There's 2 pi radians, or roughly 6.28 radians, in a full loop. So that's the meaning of that formula right there. If you want the arc length S, take the length of one radius and multiply it by the number of radiuses you wrap around to form that arc.